Guys, welcome to the season 3 of UpSkill Club. I guess you have to say it again. I'll wait for a minute. Welcome, guys. Welcome to the season 3 of UpSkill Club. This time we have our focus on system design. Across this series, we'll be discussing a lot of systems. Some of them are used specifically by urban company also, some of them are not. These are general systems. They can be as broad as design a stock uh, broken system to work on something specific like designing a rate limiter. Today our first session is on rate limiter. First question, we will start by simple questions. What do you currently understand by rate limiter? Classic definition. And I guess we'll start with Superman only. Superman, please go ahead. What do you understand by rate limiters?
लाइक अगर रिक्वेस्ट आ रही है किसी सर्वर पे तो उनका रेट लिमिट कर दे कि सारी रिक्वेस्ट एक्सेप्ट नहीं करेगा सर्वर.
Or and there are no other use cases?
नॉट श्योर.
According to me, I think rate limiter can also be used just to limit particular throughput from a particular IP address or for particular user.
Correct.
Or you could say कि for example, when I implemented for my use case, I did it to limit the number of requests for a particular user. So that can also be one of the use cases.
Yes, we do the same here also, Pranav. In today's session, we'll may predominantly learn what are the various ways to go about it. Okay, so we'll start with the classic definition, as a couple of you guys have already shared. First primary use case is preventing your system from DDoS attack. That is primary use case. Secondary use case is reduce cost. If you are limiting people who are accessing your system, you don't have to keep your system up in time for many of the users, and that reduces cost because you're not serving all of them. And third is preventing server overload, which means you don't want your server to get overloaded so that you're not able to serve the customers who are actually right customers, and your server is just not able to respond just because somebody is messing with your system and your normal users are suffering. Those are the primary use cases. Some of them that you mentioned, Pranav, are basically how do you use a rate limiter? What are the use cases that you use? These are the benefits. These are the use case, which is something as simple as you want to limit a user who should not be able to access your system more than, let's say, he cannot tweet, post, place a request more than 2 seconds, 2 times in a second. Something can be as an IP address should not be able to do that 10 times a day, more than 10 times a day. And something same, let's say people have this fraud prevention. Okay, the IP is different, user is different, but people try to do fraud by using the same device and using the rewards mechanism, sharing referral, all that on device. So all those things comes under the usage of rate limiter. Okay. The luckily our session is designed that will gradually progress toward the end design. Then we'll start by something very simple. Where do you actually put rate limiters? There are two ways. One is you can put them on the client side, which is your mobile application, web application. Yes, you can also do that. And second is, which is more widely used, which is server side. Okay. Even in server side, there are actually two ways to go about it. One, you can embed your rate limiter with your API servers. Okay, which means if you take UC's example, let's say we have growth service, we have a discovery service. So you embed a rate limiter which directly in discovery service, and discovery service manages that. Okay, hey, not many people will these many rules. These are the guidelines for people to access home screen. So those kind of things, discovery service can do that. And other way around is adding the entire rate limiting as a, let's say, system at the middleware level, which is what we do also. Which is whenever a client request is received, it doesn't directly lands on your application servers. It goes through the middleware, from where we get our auth and all that, and that is where predominantly we can also add our rate limiters. Both are right approaches. It is predominantly what is your use case. And if assume you only want and says companies at a scale that you only want to rate limit a very particular part of your system, you will not add it at let's say gateway level, or even at, let's say, the middleware level. You will add at that particular service level. So it depends on use case. uh, And in terms of pure HTTP code, whenever a request is rate limited, internet works on HTTP codes. So 429 is the request that you send back to the customer. Okay, hey, this is how your error out, which is 429, which signifies you're making too many calls. Okay. Now, question is, how do you implement rate limiter? Okay. Before I go deep down, I just want to take any amount of input. Obviously, I have read the various some sources and I have more information that is obviously given. But I just wanted to give everybody a chance to just brainstorm. If you have to implement rate limiting, not the concept, not the, let's say, the application layer, actual rate limiting on whatever application that you have written, maybe discovery service, CPRS, it doesn't matter. Whatever service that you want, how do you go about it? Take a guess. Anybody can take a guess.
I think there are certain algorithms for that.
Those we'll discuss. है ना? Yeah, those obviously we'll discuss. That is the purpose of this discussion was come. है ना? There are certain algorithms. If you remember any one of them, you can go about.
Leaky bucket is there. Token is also there.
Yes,
I know the concept of leaky bucket, so it's like more of a queue क्या push करते जाओ, but वो more like एक बड़ी bucket है, आता रहेगा, but नीचे एक hole है, तो जिस constant rate से आप चाहते हो, आप उस rate से उसको receive करते रहोगे. That is leaky bucket.
Correct. So let me move forward without any somebody has written something.
One thing, Anupam, I can share one challenge. Like instead of giving an answer, I think one of the challenge, if I think of rate limiting as a concept, one could be if there are multiple servers, and if implementing at the server side, how do you know? Like some hits are going at one server, some hits are going at some other service. How do you know? Like you have to rate limit at the total level. How do you do that? Is something that can be a challenge, and
there is a possible way of doing it by using some other intermediate in between. Either you will be using a Redis that is shared between different servers, or you can do it using Kafka also, I think.
Yep.
Correct. So whatever you both of you guys have said is correct. There are algorithms who try to do the same using that. Let's just talk about them, all of them one by one. First is the classic. Is one of the oldest one, which is token bucket algorithm. Bucket algorithm is very simple. It says there's a bucket and a lot of tokens in it. It's as simple as if you have gone to a bank and there is a machine which gives you a token, right? And only if the token is allowed, then you can go in front of the teller. Okay, hey, this is happening in my account. The same thing happens here. But if token is already overfilled, the only difference is there are preset rates of token being refilled in this algorithm. So assume there is a bucket which has which consumes 2 tokens or 5 tokens and it is updated every 5 minutes. If people don't consume it in the next round, the tokens will overflow. So the number of tokens will always be limited. That is given. Okay. This is how the algorithm works in action. Let's say there is a request which comes in. First thing that you will ask, the request will ask is, hey, are there enough token available in the bucket? If I have a token available, I'll use that token and go inside and access the application server. If they didn't, you simply drop from the request. Request is dropped. As simple as that. Okay. And it has 2 parameters, as you can see. First is the bucket size, how big the bucket is, which is, are you allowing 5 tokens, 10 tokens, 20 tokens, that matters. And then there is refilled, how quickly are those refilled? 1 minute, 2 minutes per second. Correct. And how many buckets do you need? Actually depends on the different use cases. People can have different buckets for different APIs. Hey, this API needs different buckets. People can have different buckets for at IP level. People can even have a global bucket at the middleware level, which is applicable for all requests. It will depend on the use case that you are applying the token bucket algorithm for. Cool. Second one, which is already Muskan mentioned, is leaking bucket. The difference is it is very similar. It's just that it uses a FIFO queue to process the request, and there is a rate is fixed at which it processes the request. So if the request comes in the leaking bucket, it checks if the bucket is full. If it is not, you simply add it to the bucket. And assume the analogy which Muskan said earlier. There is a leak at the bottom of the bucket, which means the requests which are actually being processed. And if you add more requests, the bucket will overflow. Same analogy. The bucket here is the queue, and they are the leak here is the number of the rate at which those are processed. So if the queue is already occupied, if you add more, they will simply overflow. Okay. It again has two parameters. First is the bucket size, how many requests are you allowing, and the outflow rate. It defines how many, at what rate you are actually taking out the request. In both of these algorithms, key thing to keep in mind is, apart from the use cases that you have, you would also need to tune in these parameters based upon your request. So this will require a lot of fine tuning on production to get it right. Maybe through people will do through it mock servers, all those things are done, but yes, they require fine tuning use case by use case, both token bucket and leaky bucket. Any input till now from anybody?
I did have a question though, but like, how does this token bucket algorithm work? Like, how does the token get refilled every time? Is there another system in place which
We'll go about those.
starts refilling it?
We'll go about those. Pratik. Those are maintained through Dix IO in Redis. All those we'll talk about once
Okay.
more. Cool. Saurav is also here. Thanks for tuning in. Chala. Next is Saurav, do you like to take this one or shall I continue?
Please continue. Anubhav.
Please continue. Okay. ठीक है. The next one is fixed window counter algorithm. This simply means every second or every for a block of unit of time, number of requests are fixed. That's it. You can choose, obviously you can choose the number of requests that you allow and the block of the time, but it is fixed. That is why it is called as fixed window. The window is fixed. You can define window. Hey, window is of 2 minutes, window is of 5 minutes, window is of 1 second, and number of requests you can also define. This algorithms is okay when there are use cases when you need a dedicated fixed window that is your use case. So what happens is, whenever a new request comes in, and if number of allowed requests are not fulfilled yet, you simply update the counter in for that window by 1, 2, 3. Like the example that we are seeing, the window is of 1 minute and number of allowed requests are 3. So if you can see, in the first minute 3 requests were requested, they were allowed. In the second minute 6 requests were requested, 3 of them were dropped. In the third minute 4 of them were requested, first 3 were allowed and the fourth one was dropped. And the fourth minute only 2 of them were requested, and subsequently for the fifth request. Okay, there is only one downside to this algorithm, and it is a major one, which is at the end of the windows, which is let's say in this use case a minute and a minute 1. So let's assume at 59 and at 001. What can happen is, purely at the end of the request you can get those requests. Okay, so I'm assuming you had a window of 1 minute and all the requests which were allowed came in at 59 seconds, correct? So you allowed those 3, and at the first minute of which is of the next window, which is the 1.1 minute, the new 3 or new 5 came in which were allowed. So technically, even though you wanted to limit the system to, okay, only 3 requests are allowed, but you allowed 6 in that period of 2 or 3 seconds. So this is the limitation of this algorithm. Okay, is that it fails at the end if there's a burst of traffic which arrives at the border conditions. Okay, that is the limitation of this algorithm, and this is where it gets interesting. And I believe this is what we use also, which is sliding window log algorithm. This is interesting. How it is very simple. There is simply number of requests which are allowed for a duration of time. But only difference is this window works like a sliding window. The last timestamp, all the window is always calculated from the last timestamp. If you see this example, let's say in this example, only 2 requests are allowed for the given window. Okay, the first request is arrived, it was allowed. Second request was received after around 29 seconds, it was allowed. The third request was immediately received in that minute at the 50th second, but it was dropped. But all these were logged. The first 2 were consumed, they are removed from the log. And the last earliest timestamp is the request that you rejected actually, which arrived at the 50th second. So now when the sliding window goes, let's say, moves forward, and you receive a request after, let's say, 30 or 40 seconds, it is allowed, because the window started at the last timestamp, which was of 50 seconds, which was earlier refused, though it counts at the starting point of the window. Okay. An example, if this is it, this is very accurate, as this algorithm is heavily used in almost all the big production systems. It keeps the rate limiting intact because you're always keeping a log of all the requests, but there is a cost of doing so. If you are keeping a log of all the requests which are coming in, even of the ones that you have rejected, there is a memory cost that you have to pay, and because you need to store all the timestamps. Gaurav is smiling, so please go ahead.
Somebody is asking a question.
Yeah, I have one doubt that in the fourth step, we are allowing the 1 minute 50 second request. But in the third step, it should be dropped because it was the third request.
थर्ड पे ड्रॉप हो गया है, चौथे पे एक्चुअली जब चौथी रिक्वेस्ट आई है, तो 1 मिनट में 2 रिक्वेस्ट अलाउ होना था, दैट वाज द कंडीशन, ठीक है, 1 मिनट में ओनली 2 रिक्वेस्ट विल बी।
तो फिर वो जो ड्रॉप रिक्वेस्ट थी प्रीवियस मिनट में, वो हमने कहीं स्टोर करके रख रहे हैं क्या उसको?
हाँ, यस, तो आपको कहीं रेडिस में, मोंगो में, जहां पर भी आप मेमोरी मेंटेन करेंगे वहां स्टोर करना पड़ेगा। तो सिंपलीफाई, पहली रिक्वेस्ट आई पहले सेकंड में, ठीक, एज यू कैन सी 1001 वो अलाउ हो गई। अगली रिक्वेस्ट आई तीसरे सेकंड पे, तो वो 0030 पे अलाउ हो गई, तो दोनों चले गए अंदर। अब स्टार्टिंग विंडो क्या हो चुकी थी उसकी, 001 इज द स्टार्टिंग विंडो, करेक्ट, वहां से टाइम चल रहा है स्लाइडिंग विंडो का। अब तीसरी रिक्वेस्ट है 0530, क्यों, 60 मिनट में 2 ही अलाउ करनी, तो रिजेक्ट हो गई, करेक्ट।
तो स्लाइडिंग विंडो में मतलब ये है कि रिक्वेस्ट ड्रॉप नहीं होते?
रिक्वेस्ट ड्रॉप होते हैं, तीसरी रिक्वेस्ट ड्रॉप होगी इस केस में, क्यों, आपने 1 मिनट में 2 रिक्वेस्ट अलाउ करने का सोचा था, ठीक है, एक
पर वो नेक्स्ट मिनट में कंसीडर हो जाएगी ना, जब
नहीं, उसने रिक्वेस्ट को टाइम स्टैम्प को स्टोर कर रखा है, लेकिन रिक्वेस्ट को वो डिनायल दे देगा।
हाँ, जैसे तुम थर्ड रिक्वेस्ट में देखो, थर्ड इज इट इज डिनाइड, तो मेंटल मैप बनाओ बस सिंपली, 1 मिनट में 2 रिक्वेस्ट अलाउ करनी है, ठीक, पहले सेकंड में रिक्वेस्ट आई अलाउ हो गई, 30th सेकंड में रिक्वेस्ट आई अलाउ हो गई, ठीक, दोनों कंज्यूम हो गए, ठीक। अब स्टार्टिंग पॉइंट अभी भी क्या है, पहला सेकंड जो था वो तुम्हारा स्टार्टिंग पॉइंट है टाइम स्टैम्प का, तो पहले फर्स्ट सेकंड से लेकर अगले मिनट के पहले सेकंड तक वो विंडो काउंट होगी, करेक्ट। तो जब तक ये विंडो काउंट होगा, अगर अगली अब तीसरी रिक्वेस्ट आई 85 सेकंड पे, तो रिजेक्ट होगी,
ठीक है,
ठीक। अब पहली स्लाइडिंग विंडो नीचे मूव करेगा थोड़ी देर बाद, विच इज एक सेकंड, थर्ड सेकंड, फोर्थ सेकंड, फिफ्थ सेकंड, सिक्स्थ सेकंड, ऐसे ही 30th सेकंड पे हिट करेगा नॉर्मल टाइमर के बाद। 30th जो सेकंड थी, जो सेकंड रिक्वेस्ट का टाइम स्टैम्प था, वो विंडो बन जाएगा तुम्हारा। उस विंडो से लेकर अगले मिनट के 30th सेकंड तक अगर कोई रिक्वेस्ट आती है तो वो अलाउ हो जाएगी, अगर एक आती है तो। इस वाले एग्जांपल में 30th की बात भेजा है टू मेक इट और इजी। तो जब भी जैसे ही रिक्वेस्ट पहली कंज्यूम हो जाती है, वो फर्स्ट स्टार्टिंग चेक पॉइंट बन जाता है हमारा अगले विंडो के लिए, जो भी विंडो की आपने वो विड्थ डिफाइन कर रखी है, 1 मिनट हो, 2 मिनट हो, 5 मिनट।
तो ये 50th वाली जब फर्स्ट 2 रिक्वेस्ट थी तब तो ड्रॉप हो गई, पर फिर नेक्स्ट वाली विंडो में तो फिर वो एग्जिस्ट नहीं कर रही
ड्रॉप हो चुकी है, 50th वाली ड्रॉप हो चुकी है, इट इज ओनली बीइंग यूज्ड। तो इमेजिन करो 1 2 3, थर्ड वाली ड्रॉप हो चुकी है, लेकिन उसका जो टाइम स्टैम्प था वो यूज हो रहा है अगली विंडो क्रिएट करने के लिए।
अच्छा, मतलब ड्रॉप तो हो गया बस टाइम से, ठीक ठीक।
हाँ, कि मतलब तीसरी रिक्वेस्ट मना कर दी थी, लेकिन वो कब आई थी वो, और उसका नेक्स्ट प्लस 1 मिनट उतने में कितनी अलाउड है अब
ठीक
है। कूल, देन दिस इज अ लिटिल ट्रिकी। इसमें बस ये बताया जा रहा है कि दिस कम्युनिकेशन।
एक क्वेश्चन था, क्योंकि हमारा पहले अच्छा जो लास्ट ड्रॉप हुआ है उससे हम नेक्स्ट टाइम स्टैम्प स्टार्ट करते हैं क्या?
यस,
ठीक है।
तो अलाउड से क्यों करोगे, अलाउड तो हो ही चुकी है ना।
नहीं, जो नेक्स्ट टाइम विंडो होगा वो ये क्वेश्चन है 10050 से 10150 तक होगा,
हाँ, 151
या 10140 से लेके 10040 तक होगा।
हाँ, तो हिमांशु मैं वही कह रहा हूँ बेसिकली, हमने कहा था कि जैसे 1 मिनट में 2 रिक्वेस्ट अलाउ करनी है, तो जैसे अभिजीत का क्वेश्चन था ना कि 1 अलाउड हो गया, 30 सेकंड पे जो आया वो भी अलाउ हो गया, सही है। फिर थर्ड वाला जो है, अच्छा वो 50 पे था, वो ड्रॉप हुआ है, 50 वाला ड्रॉप हुआ है।
यस, 50 वाला ड्रॉप हुआ होगा ना।
हाँ ठीक है, कूल है, सही है
50 वाला ड्रॉप। और जब भी नई रिक्वेस्ट आती है जो कि सक्सेस करती है, वो पुराने सारे टाइम स्टैम्प उड़ा देती है।
हाँ, मेक सेंस।
वो सारे पुराने वीडियो टाइम स्टैम्प उड़ा देती है, वो अलाउ हो गई थी।
ठीक है।
तो अनुपम इसमें अगर 55 पे आती 100 55 पे तो ले लेता और फिर 1 मिनट में 2 से ज्यादा हो जाती।
नहीं फेल हो जाती उस केस में।
नहीं 55 को वो नहीं लेता ना कि 2
नहीं
रिक्वेस्ट
लेता,
पर
वो
मिनट का है
हाँ,
आपका, और पहला आपका 10001 से स्टार्ट हुआ है,
एक मिनट
तो
खत्म ही नहीं हुआ है ना, एक तेरा विंडो शुरू हुआ था 001 पे, एक मिनट की विंडो शुरू हुई थी, ठीक है। वो विंडो में अब तुमने 2 कंज्यूम कर लिया, जब तक वो विंडो खत्म नहीं तब तक नया टाइम स्टैम्प नहीं पिक करेगा ना वो लास्ट। जैसे वो विंडो खत्म हुई वो मेमोरी में जाएगा, लास्ट टाइम स्टैम्प उठाएगा, वहां से वो विंडो कैलकुलेट करना शुरू कर देगा अब इतने में कितने को अलाउ करना है नेक्स्ट।
अच्छा ठीक है।
विंडो स्लाइड होने का कोई क्वांटम नहीं है कि पर सेकंड पे मूव करेगा, ये फिर ये है कि रिक्वेस्ट का जो सीक्वेंस है उस पे मूव करेगा।
हाँ
ये रिक्वेस्ट के सीक्वेंस पे मूव करना पड़ेगा ना, तभी फायदा है सारे टाइम स्टैम्प स्टोर करने का। अगर टिक पे मूव कर रहा होता तो सारे टाइम स्टैम्प क्यों डालता है?
हाँ हाँ cool guys, this is what we use in UC also. Saurav is here to deep dive in the same further, right Saurav? Yes, ठीक है। Then there is another one which is a little bit of hybrid model, which is rolling window है लेकिन परसेंटेज बेस के हिसाब से निकालेंगे। तो रोलिंग विंडो है, जैसे एग्जाम्पल ये थोड़ा सा कॉन्वोल्यूटेड है। एग्जाम्पल अगर ये यूज केस देखो कि लास्ट ये लगातार रोलिंग विंडो फिक्स चल रही है, दोनों को मर्ज किया इन्होंने स्लाइडिंग विंडो और फिक्स विंडो काउंटर को मर्ज किया है। कैसे किया है इन्होंने कि अगर जो करंट लास्ट की जो लास्ट का काउंटर था, जैसे एग्जाम्पल मिनट, हर एक मिनट या फिर हर एक ब्लॉक ऑफ टाइम जो भी आप डिफाइन करते हो, दैट इज वेयर इट गेट्स कैलकुलेट, और बीच में भी वैसे ही कैलकुलेट होती है। वैसे अगर आप लास्ट ब्लॉक से नए ब्लॉक में आ गए, ये बाउंड्री कंडीशन पे हो, और अगर आप पीछे वाली कंडीशन में आपने 30 उसका 70% बचा हुआ है और नए वाले में 30% एंटर कर चुके हो उस ब्लॉक ऑफ टाइम में, तो दोनों को परसेंटेज से डिवाइड करके निकालता है कि क्या लिमिट होनी चाहिए। एग्जाम्पल इस केस में 70% पिछले वाले मिनट का चल रहा है, ठीक है, और 30% वाले नए मिनट का टाइम विंडो चल रही है, विंडो बस स्क्रॉल कर रही है। अब पिछले वाले 70% में आपके 3 रिक्वेस्ट आई थी, ठीक है, नए वाले में भी 3 आई, ठीक। तो दोनों को मल्टीप्लाई करके निकालता है कि पिछले वाले में 5 आई थी तो वो लेकिन 70% था तो 5 × 7.5, और नए वाले का विंडो एब्सोल्युटली 3, तो नेट रिक्वेस्ट कितने हैं आपके पास 6.5। तो ये थोड़ा सा कॉन्वोल्यूटेड है, ये समझ में आ रहा है नहीं आ रहा? कि जो आप एग्जिस्टिंग विंडो वो तो पूरा कैलकुलेट होगा, जैसे 3 है 4 है 5 है 6 है, करेक्ट 6 है जितनी भी आ रही हैं और कैलकुलेट करने से, लेकिन आप जो पिछला विंडो से जितना भी परसेंटेज आपको बचा है, जितना भी परसेंटेज उससे मल्टीप्लाई करके निकाल लेते हैं कि कितना एग्जिस्टिंग विंडो का थ्रेशोल्ड कितना है। जैसे इस केस में पिछले वाले विंडो का 70% बचा हुआ था, लेकिन उन 70 में 5 रिक्वेस्ट वर सर्व्ड, ठीक, और नए विंडो में 3 रिक्वेस्ट आ चुकी हैं नए वाली। तो यह भी क्या कैपेसिटी निकाल रहा है कि 3 तो नए विंडो की है, विच जो एग्जिस्टिंग विंडो चल रहा है, एंड पिछले वाले विंडो में 5 आई थी लेकिन उसका 70% ही बचा है, वो पूरा विंडो कैलकुलेट नहीं हो रहा है। दिस कम्स आउट टू बी 3.5। तो 3.5 और 3 6.5 निकालता है, कोई इसने राउंड फ्लोर लगा रखा होगा, और अगर लिमिट 7 होगी तो अगली रिक्वेस्ट को अलाउ करेगा ये 30 उस पॉइंट ऑफ टाइम में, एल्स रिजेक्ट कर देगा। तो ये लगातार परसेंटेज कैलकुलेशन करता रहता है, अगले सेकंड में वापस 69 हो जाएगा, 68 हो जाएगा, ऐसे मूव करते रहेगा। ये समझ में आ रहा है?
टाइम का परसेंटेज निकाल रहे, राइट है ना?
ये मतलब हाँ, टाइम जितना ब्लॉक का परसेंटेज
ब्लॉक का
निकालता है वो निकालते हैं, उसको देन मल्टीप्लाई करते हैं कितनी रिक्वेस्ट सर्व हुई थी उस विंडो में, उस विंडो में, और जो नई रिक्वेस्ट होती है वो एज इज। अब ये दोनों मिला के अगर थ्रेशोल्ड क्रॉस कर जाते हैं, मतलब यार हमने पहले बहुत ज्यादा अलाउ कर दी थी, अभी कम लोगों को अलाउ करो, इसका मतलब ये है एक तरह से, समझ रहे हो कि बहुत पिछले वेटेज मतलब बहुत ज्यादा था, लेकिन वेटेज वो लेता है वो कितना विंडो का बचा हुआ था, इट इज सिंपली वेटेज कि लास्ट टाइम स्टैम्प की तरह कितने अलाउ की थी, ताकि नई रिक्वेस्ट जो आए वो थोड़ा सा मैथमेटिकल हो जाए, इंस्टेड ऑफ यू कॉन्फिगरिंग इट वेरी हार्ड कोडेड, वो टॉप लेवल बस हार्ड कोड क्रिएट होता है कितनी अलाउ करनी है। तो विंडो का भी मिस नहीं हो सकती। अब अगर किसी ने बर्स्ट कर दिया ना लास्ट एट द एंड ऑफ द उस पे, इमेजिन करो 70% बचा हुआ था, लेकिन किसी ने बर्स्ट कर रखा था, 8 रिक्वेस्ट अलाउ 7 रिक्वेस्ट अलाउ कर रखी थी, तो 4.9 आ जाएगा यहाँ पर, करेक्ट 4.9 आ जाएगा, ओनली 2 रिक्वेस्ट अलाउ करेगा उस केस में, और तीसरे बार मना कर देगा कि नहीं भैया आप तो 7 क्रॉस कर दोगे जो कि हमारी लिमिट है। क्वेश्चन स्टिल नाउ? I'll recall. So one of my favorite thing is to repeat. ठीक, so we'll repeat all the algorithms.
मैं ये कहूँगा अनुपम, एक चीज ओवरऑल अगर हम कंपैरिजन करें, मतलब तीनों एल्गोरिथम्स का मोटा मोटा, या चार एल्गोरिथम्स है, तो क्या मतलब व्हाट्स आर द प्रोज एंड कॉन्स, मतलब मुझे कुछ कुछ दिख रहे हैं अपेरेंटली,
Pros and
जैसे
cons
फॉर
मैं थोड़ा
एग्जांपल।
simplify करने को let's talk about them. For
हाँ
token bucket, which is कि bucket में if you have enough content in the bucket or not, the limitations are algo is memory efficient, correct? क्योंकि आपके bucket की size fixed है, ठीक है? But जब भी वो आएगा ना, it will also allow burst of traffic because अगर आपने simply number of buckets आप बहुत easily tweak कर सकते हो, लेकिन आपको फाइन ट्यूनिंग करनी पड़ेगी उसमें, ठीक है? तो this requires you fine tuning a lot, ठीक है? That is its limitation. इफ यू टॉक अबाउट लीकी बकेट भी मेमोरी एफिशिएंट है क्योंकि क्यू की साइज फिक्स्ड है ना? और जब भी स्टेबल आउटफ्लो का रेट होता है कि भाई हमें दिस कैन बी कि स्टॉक का प्राइस बहुत जल्दी जल्दी अपडेट होता है, लेकिन हमें अपडेट बस 1 सेकंड में एक बार ही करना है। लेट्स से दैट इज द यूज केस ऑन योर मोबाइल एप्लीकेशन और बैकएंड एप्लीकेशन। लोग खरीद रहे हैं, हो रहा है ना कि लोग एकदम बहुत ही रियल टाइम नैनो सेकंड पे प्राइस पे बेच रहे हैं, खरीद रहे हैं, लेकिन जो आपके मोबाइल एप्लीकेशन जो प्राइस दिखा रही है जिस कैन नॉट डू दैट, और आपको आउटफ्लो रेट थोड़ा सिंपल रखना होगा। तो अज्यूम कि एक स्टॉक है जिसकी प्राइस आए जा रहे हैं, बट वो हर 1 सेकंड पे निकाल रहा है, ठीक है? अब क्या प्राइस थी, अब क्या प्राइस थी। फॉर दोज यूज केसेस, उस टाइप के यूज केसेस विच इज ऑफ हाउ सर्वर एक्सेप्ट्स रिक्वेस्ट, उन यूज केसेस के लिए ये वाली लीकी बकेट मेक सेंस। दिस ऑल्सो अलाउ, इसमें ओनली कैविएट है कि ये अगर एकदम बर्स्ट ऑफ ट्रैफिक आ गया तो क्यों भर जाएगी आपकी, करेक्ट? कि एकदम विंडो के स्टार्ट में एंड में कहीं पर भी एक बार बर्स्ट आ गया तो आपकी विंडो भर जाएगी और पूरे ड्यूरेशन तक आप ब्लॉक रहोगे। तो पीपल कैन लिटरली पीरियोडिकली सेंड डॉस अटैक आपके पास कि अगर इनका रेट लिमिटर 1 मिनट का है तो हर 1 मिनट 1 सेकंड पे 50 रिक्वेस्ट भेजो, अगर इनकी 50 की है तो ब्लॉक हो जाएगी आपकी क्यू। क्यों? आपने क्यू तो फुल करवा ली ना उनसे, आपने बाउंस मारने की जगह फिल करा दिया आपसे, तो आपकी क्यू भर गई, अब जेन्युइन रिक्वेस्ट ड्रॉप हो रही है। दैट इज लिमिटेड, ठीक? और अगेन क्योंकि इसमें आउटफ्लो एंड बकेट साइज है तो दिस आल्सो रिक्वायर्स फाइन ट्यूनिंग ऑन प्रोडक्शन।
अनुपम, क्या ये लीकी बकेट हम क्लाइंट साइड पे इम्प्लीमेंट कर सकते हैं?
क्लाइंट साइड पे कर सकते हैं, लेकिन नॉर्मली नहीं करते। क्लाइंट साइड विल टॉक अबाउट क्लाइंट साइड आल्सो, कि जो आपने देखा था कि रिक्वेस्ट का एरर टाइप भी रिटर्न एज 429 एंड उसके हिसाब से क्लाइंट को कैसा बिहेव करना चाहिए। विल टॉक ब्रीफली अबाउट दैट नेक्स्ट।
ठीक है।
One more question, अनुपम, कि do we configure these buckets या फिर rates based on the time, मतलब जैसे रात के लिए do we configure it separately and for morning?
वो रूल्स आएंगे, we'll cover that in rules part. Yes, so that is part of how do you define rules. We only talked about algorithms right now. We'll talk about rules also. Cool. So let's talk about the next one is fixed window counter algorithm. Again, this algorithm is efficient. It has a primary limitation of you can allow a lot of traffic if you send them at the window ends. That is its limitation. Sliding window is one of the most fail-proof ones. That's why it is used very much. Its downside is because you need to store all the timestamp, even though request was rejected. There is a memory cost, so there is a extra cost attached to it. It is not memory efficient. Then the other one is similar. It is similar. It smoothens out traffic. What does that this means is if there is a surge of traffic, it will not allow traffic for some time. Then if there is a stale period, it will allow a good amount of time. That it smoothens out traffic. कि ज़्यादा लोग भेज रहे हैं, कम को allow करो, कम लोग आ रहे हैं तो ठीक है, कि average rate से कई सारे लोग आ सकते हैं. This is what it allows. ठीक? So all those algorithms are predominantly used at UC and everywhere else also at the middleware. So this is how the entire HLD normally looks like. You have a API server and there is a rate limiter middleware जहाँ पे middleware बना हुआ है, client से request आती है and आप अपने rules हो या कुछ हो आप store करते हैं Redis पे ताकि easily access कर सके। Redis पे store करते हैं, हाँ, let's say अगर आपको timestamp भी store करना है in case of sliding window protocol, ठीक? This is the normal HLD what it looks like. What you were talking about earlier, Aryan, is how do you define rules? है ना? They are normally saved on disk, ठीक है? And they are easily accessed through obviously caches and all that. And there are workers which configure these rules in async manners, and they get updated. So yes, you can configure the workers कि hey, at this time or at this time frame change the rule. At this time frame change the rule. Yes, you can do that, but you have to create a mechanism on top of the workers that those are there. रूल्स की जो वैल्यू होगी वो एक ही रहेगी एक टाइम पे, वर्कर्स अलग अलग टाइम पे अलग अलग कर रहे होंगे। तो आपका सिस्टम विल नॉट वर्क ऑन बेस्ड ऑन वैल्यू ऑफ रूल, इट विल वर्क ऑन टॉप ऑफ द वर्कर्स दैट यू हैव. Okay, the one thing that you wanted to know, Pranav, is okay, these are the classic globally accepted headers, which is कितना लिमिट रह गया अभी आपको, नंबर ऑफ अलाउड रिक्वेस्ट व्हिच आर रिमेनिंग. ये हेडर्स में इंफॉर्मेशन वापस रिटर्न की जाती है, लिमिट रीड कितनी है और अगर कितने देर बाद रिट्राई करो. So this is what the server sends back and to the client. Hey, if you have been rate limited, and this is the amount of second that you should, if you're a genuine user, this is the amount of time you should come back again. And client which are smart, let's say अभी हम ऐसा नहीं करते हैं हमारे rate limiter से case है, we are not configuring it on our clients. If you need to retry, we don't send any information to clients so that for it to retry. We assume it to be bad traffic because for us it happens in outages cases, and clients our actual clients press a button and retry. Okay, and various use cases when there is a lazy call and it has been rate limited, server will send back, hey, you were rate limited, but call us back after this much time. So then you communicate that information through the error code and the header information. Okay, and this is the LLD of, let's say, an actual production system. Let's see how this will look like. Client sends a request, it is received on the rate limiter middleware. Rate limiter middleware goes to the cache, and the cache, it has the rules which are updated by workers. Rules are actually written on in actual proper disk. Workers update the disk and the cache. Okay? Workers update the disk and the cache. So whenever you are, let's say, Arvind, you wrote a rule ki allow very less amount of traffic in the evening so that there is no server cost. From EC2 instances, we don't have to host them a lot, and you want to control that through rate limiter, you can do that. And these workers will update not only your cache, which is accessed by your middleware, also the rules, so that if in case the cache is faulty after it goes for a tang, it can be updated through the database. If request was allowed, you go through the application server and do your job, and this for based upon various algorithm that you are using. If you are storing timestamp, if you are storing anything else, it is accessed through the Redis. Okay, and if it is rate limited, you send back the request to client ki, hey, with 429, hey, you are sending too many requests. Now you have two options. Some people decide the request will simply be dropped, and some people keep a message queue independently so that either they can process it again themselves, or simply use this information to send any consumer related messages. Cool. Any questions on this LLD? Not really, technically.
Nupam, so there is a cache rules and then there is Redis. I didn't understand basically.
Cache rules basically constant files की तरह पड़ा हुआ है, ऐसा मान लो, ठीक है?
ठीक है, हाँ हाँ.
पड़ा हुआ है, और ताकि तुम rate limit कर पाओ, तो you don't have to go and let's update it.
Correct.
Basically, you will use, assume you had sliding window protocol, and you continuously have to update it in some way, right? And
okay,
fast also.
ठीक है.
You would need a let's say distributed cache in order to do that, because in distributed system rate limiter are also distributed, correct? Those are the problems which happens in a distributed system. You need to synchronize also, ठीक है? Synchronization की problem आएगी कि अगर आपने एक ने rate limit कर दिया, उसने rule allow कर दिया. Assume somebody rate limited, but you received a request on the first rate limiter at T1 timestamp, and that window started, and you receive a request on the second T1 plus some delta T, which is T2. First guy will check the window and will allow you. Second guy will also check the window, will allow you. Though second one should have been let's say rejected. Those are the problem of synchronization. And then there is performance. Performance basically is based upon where you are situated. This is basically solved through infra solution, Cloudflare and all that. So it is not for our sake. So this makes sense, Pranav?
Yeah.
Okay.
एक क्वेश्चन है which is not related to this LLD, but मतलब I was thinking about कि जैसे जो load balances होते हैं, उनका भी काम यही होता है कि जो multiple request आ रही हो, कुछ भी उनको balance करना, distribute करना, and अगर over आ रही हो तो उनको रोकना. तो what was the need कि rate limiter की need arise हो, मतलब load balancer कर तो रहना ही काम, मतलब कि कितनी request जानी है उसको restrict करना.
नहीं तो
yeah, actually load balancer would just distribute the load. It doesn't have to care about can this container deal with this much load. It would just take in request and would send to जितने भी आपके पास containers or machines and will try to distribute based on some policy. It doesn't care about can that client handle it or not.
And
rate limiter.
And it will not reject the traffic, right?
Yeah, it would not reject the traffic. That is at the server level.
You hit the load balancer when you have entered the system crossing the rate limit.
Also, a simple example is if you just can't serve more than 100 requests, load balancer will serve 10,000 requests, but it will distribute it across all the servers. You need rate limiter to stop it to, let's say 100 or 1000. The job of load balancer is just to balance the load, not to limit the load. That is why you need rate limiter extra.
Got it.
like,
But that could have still हमारा चॉइस ना, मतलब लोड बैलेंस की एल्गोरिथम में उसको ट्वीक करना, वो भी तो पॉसिबिलिटी थी. मतलब रेट लिमिटर ही क्यों?
ये तो रेट लिमिटर ऐसे समझ लो कि needs to identify कि if this request is allowed or not. Okay, load balancer identifies who needs to serve this request.
Okay.
Okay, example of a simple example of real world can be rate limiter allows, let's say there is a very big buffet, okay, and there's a hotel. So rate limiter acts as the guard which allows, hey, you're not maybe well dressed for the event, or too many of you are coming, ruk ja, there is people are occupied inside. That is a role of a guy who is standing at the flag end. And load balancer, once you enter in, it acts like a reception. Hey, you need to go to this room, you need to go to this room, you need to go to this room, so that all the rooms are occupied and those are served. Better on the buffet is occupied and served. Cool.
भाई पर दोनों केस में रेट लिमिटर और लोड बैलेंसर दोनों केस में कंटेनर कितना अभी प्रोसेसिंग पावर है उसके पास या कितना रिक्वेस्ट हैंडल कर सकता है, दोनों को ही तो पता है. तो
rate limiter doesn't cares about container number of containers, or let's say the CPU currently allowed, the memory currently allowed. It doesn't cares about that. It simply cares about should we even take this request. That's it.
पर रेट लिमिट तो हम उसी बेसिस पे करेंगे ना कि वो हैंडल कर सकते हैं कि रिक्वेस्ट.
So we identify what is the usage pattern of our application. That is what we want to identify. Hey, a normal customer for us, if it is a genuine customer, who should not be making more than 5 requests in a second. Correct? Correct? Who serves that, it doesn't matter. If we increase that limit to 10, who serves that doesn't matter. So that job is for load balancer. Hey, who should serve this request efficiently? If it is allowed or not, that is what we try to throttle through our rate limiters.
I would like to add one more thing to this, Muskan, ki basically load balancers actually do a lot more. For example, it also it also has the rules. Basically, it also actually checks if any of the servers within that particular cluster are down or not, or whether any new instance needs to be created. If new instance is created, that has to be added to the that particular group, and within that load balancer, that is also things that load balancers handles. This is late limiter is exactly like just Anupam said, it has a different set of responsibilities.
Also from the chat, Pratik, these are algorithms. They are used for rate limiting. They can be used anywhere else also. So you're right. So we can use leaky bucket for our OTP generation. You're right there. And it's just that these algorithms are generic in nature, and those are used for predominantly for rate limiting. You can do it for incoming requests. If you want to consume a logic or not, or they can multi-purpose usage of these algorithms. Cool. I don't know this code, so I guess I'll pass on the baton now to one of our esteemed guests for today, which is Saurabh Jujoria. Please, Saurabh.
इससे पहले भी there is one more thing that happens. So platform team has created a dashboard. If you open on config.urban company.
This is it.
Yeah, here basically you can define the rules. So Anupam was talking of cache rules now. So these are basically those for a particular service or API, and these can be at 3 levels. One is API, service, and also you can send it basis client. There's an option to add client. Only limit, let's say only entertain this much traffic from web.
Android, iOS, and all that also.
So 3 levels, and this goes to your platform config service. There's a service platform team maintains. Is it platform service or platform config service? And it stores it in its DB, all of these values. Now, how does this actually work at the open API level is इससे पहले भी if you go to a file, just
do I need to open something for it?
yeah, there's this one thing called initiate cache.
Stop sharing them.
I'll project it now. One thing which happens even before this. So this is called as a middleware when your service is starting up, and it's added as a middleware to your service basically. And what is happening inside this function को एक बार बताते हैं. So rate limiting policy is how is this polling part working? So OpenAPI is a library which is running, which is into your node modules. But how is it fetching continuously the updates that are happening in a platform config service? So what they do is they have set interval which is running at I think every 10 seconds.
Yeah, run over 60.
Yeah.
Sync rate limit policy sync time seconds. Line number 15.
Yes.
Line number 15 है. 15 into 1000 क्या हुआ?
यहाँ पे भी so at every like some policy set within OpenAPI constant into these many seconds, it's continuously polling your platform config wala service and storing the parameter, which is your policy, at its local storage level, which is singleton. Basically, singleton when they have added a variable, which is taking care of that. Now
it is same as the workers and local cache and the database design, which is there is a
yes, and from that XLD, it's basically this part, but it's happening within OpenAPI. Now, once a request comes, it is basically distributed. The challenge here is you have multiple containers running. You have set the rate limit for the overall service, but this code would be running in every container of the service, right? Because this is independent. Every service a container would have its version of OpenAPI running. So how is it taking care of that part? What they do is they distribute it at container level. So they have some infra utility to get the number of containers of this service. Now what they try to do is basically at each container, if the overall service counter is itna, then how much is the distribution at each container? So what they try to do is they set to the limit as per the distribution into the containers. So let's say you have 10 containers. The overall request we have set 100 requests you should be able to take in any defined time interval. Then it would distribute 10, 10, 10 per each container. Okay. Now, once a request comes, 2-3 checks are done. One is to basically check if the token is available. So this is run whenever a request is coming. It's a part of the middle. So what it first checks is this request allowed? And it has this hierarchy is basically nothing but it's checking at 3 levels. One is the client level thing allowed, is the API level rate limit allowed, and is the service level rate limit log. Because you can configure at 3 hierarchies. And if all of them are true, then only you allow the request to be processed. Else you just drop it. We don't send anything to the queue. We just drop the traffic, unlike the HLD diagram. Now, once you have allowed the request, you have to decrement at each of these levels of hierarchy. Like service में से भी account decrement करोगे, API में से भी, and then client level पे भी. And this decrement token is basically taking care of that logic. It's getting the policy from the singleton. Then it gets time window MSS, basically whatever time you have set in your config dashboard. Is it like these many requests for 1 minute, these many requests for 5 minutes, or something like that? It first tries to check whether the last or the start of the window, whether this request is within this window. So basically, you took the start of the window, you try to add window size to it, and you see whether current time is within this window boundary. If it is, you decrement the count. Else, what would happen is basically you have passed the previous window and a request has arrived. In that case, you reset your timestamp, or basically slide your window to the new timestamp and set the count accordingly. So yeah, what this? It tried opening the account. And this is all maintained at cache level, which is at Redis. So what they are basically setting is token bucket key. What is token bucket key? I will check. It would basically be some signifier of this container. That would be actually container count. Token bucket key would be some signifier of whatever rate limiting rule it was. Token limit is token limit per container, which is the amount you have limited per container. In our example, we limited it to 10 if 100 requests were allowed at container. Container count, not necessarily. This is, they are logging that. I'm not sure if this would be available at raw DLT logs, we can check. But basically what they say at cache level is they take the key. Token bucket is the object they created, which is start of the window and how many tokens do we have left for this container. And time window MS is basically the new timestamp or the, yeah.
Correct. We're able to see that they're using tokens, but we're not able to see what is how they're updating the window, right? Is it fixed or is it sliding?
It's sliding only now. So what they're doing is, let's say first, this is your first ever request on the platform, or when you set the policy, you will fall into this else condition, right? You would set the timestamp as current time. You would set something as the token count, and then the next request comes. You will check whether, okay, the start of the window plus the window size, is my current request within this window? If yes, then you'll basically try to do token allocation if the token is available on.
Fair enough. And this also works with load balancer, because if a request is arrived later on some other containers, for that guy, bucket will simply start late.
Yeah.
Yeah. So that is how. So if whenever we are setting a limiter, let's say 1,000 requests a minute, and there are, let's say, 10 containers, so that is distributed like 100 requests are actually applicable for at a container level. And whenever the first request arrives, that starts the window, and then the timestamp and the limit is of, let's say we have 1 minute, right? How much minute do we have? A minute. We are updating at a minute. Bucket sizes was 60 into 1,000 only, right? 60,000 ms.
At what frequency are we updating the cache?
No, what is the bucket size for us currently?
That you are setting from the dashboard. Matlab bucket size is in
window size.
Yeah, that's
window size is an input here. Okay.
That you are setting from the dashboard.
Actually, this is container level rate limiting. Right?
Yes, this is container level.
Exactly, service level exact नहीं बैठेगा calculation.
And
it is not even implemented. It is container level only. Service just it is
It's an
configuration at service level.
it's an approximation. You are
Yeah,
assuming
approximate.
every container,
Yes. Yes.
every
Yes.
container would get equal load.
Yes. Yes.
And there's a big catch in this strategy, because let's say if you put 500 requests at a service level and there are 5 containers, you really rely on your load balancer to work really well.
To divide 100 each and that too at the same timing, like time
Right,
distribution भी ले रहा है वो ध्यान में.
So
Yes.
there is a here, but this also works in the cases if any of the containers goes down also, right? And what should happen whenever we are deploying when container counts gets doubled? That whenever we deploy, container counts gets doubled. In that case, it should either many of the requests might get dropped if this is the case, right?
If the container count doubles,
it doubles instantaneously, correct?
कुछ
then
seconds के लिए I guess अनुपम drop करता होगा because they are calculating number of containers at every request. मतलब वो हमेशा शायद ये देख
अरे वो 10 सेकंड की जो
For
विंडो
that
होती है ना,
window,
वो 10
तो
सेकंड की विंडो में वो इशू आता होगा क्योंकि वो 10 सेकंड की विंडो में रीफेच करता होगा ना कॉन्फ़िग को, तब आता
then
होगा.
it tries to do this.
हाँ, लेकिन वो बहुत वो एज केस है. आई थिंक आर्यन ने भी सेम केस डिस्कस किया था सुलभ
Why
के
is it
साथ.
an edge case? We deploy it 5 times a day, let's say, on a service.
आप वो केस कह रहे हो ना कि अभी 10 कंटेनर सडनली 12 हो गए,
20 हो गए, 20 हो गए,
20 भी हो गए, बट आपके रेट लिमिटिंग रूल्स
ये में इंटरेस्टिंग पार्ट है. We should look back. मतलब
अरे जब 20 कंटेनर चल रहे हैं तो उन 10 सेकंड में जब वो फेच करेगा तब उसको 100 मिल रहा होगा, राइट? तब भी 100 को वो डिवाइड करना 20 से करेगा और थोड़ी देर बाद जब फिर से फेच करेगा 100 तब 10 से डिवाइड करना शुरू कर देगा.
हाँ,
तो जो लोड
थोड़ा टाइम स्टैम्प के लिए वो पुराने जो आपके 10 कंटेनर्स हैं, those might actually like
serve more requests.
More requests. Yeah, serve more
They're not actually will not limiting. They're actually allowing more requests than needed for that deployment period. We're not actually limiting it. It is same कि हाँ जब if somebody times it with our deployment, it will be based upon insider trading. So if somebody times it well, they can get a lot of requests passed.
Or you can raise it as a bug face in this code.
I think हमारे स्केल के हिसाब से भी वो सही चल जाता है.
बड़े लेवल पे दिक्कत आती होगी मतलब फ्लिपकार्ट लेवल.
क्योंकि मनीष वाला पॉइंट बहुत वैलिड है. अगर लोड बैलेंसर सही से हल्का सा काम नहीं करता और एक ज्यादा लोड दे रहा है, देन वहां पे तो रेट लिमिटिंग इम्पैक्ट आने लग जाएगी, जबकि ओवरऑल ट्रैफिक हमारा बहुत कम चल रहा है.
या
मे बी नेक्स्ट
हम लिमिट करेगा वो, मतलब
हाँ
1000 बोल के वो 500 ही कर देगा क्योंकि आपने एक ही कंटेनर पे सब फेंक दिया, तो आपके रिसोर्स अंडर यूटिलाइज होने लगेंगे.
Resource underutilized होने लगेंगे. But let us deep dive into load balancer in upcoming sessions, so that thanks guys. I guess Saurabh, anything else that you guys want to ask Saurabh? Not me, obviously.
Anyone can answer. I would like to ask कि यार मतलब it seems to me कि ये भी हमारी overall request response की journey में कुछ latency add करता हुआ. Is it a fair assumption?
Good question.
आई थिंक क्योंकि कंटेनर लेवल पड़ा हुआ है तो बहुत माइनर करता होगा. बीच में अगर सर्विस लेवल होता तो बीच में रेडिस लगानी पड़ जाती तो मेजॉरिटी ऐड कर रहा होता, बट राइट नाउ इट शुड बी नेग्लिजिबल, राइट?
समझ गया. हाँ, makes sense.
But बहुत ही मिनिमम कॉस्ट तो आ रही होगी. बहुत ही मिनिमम. बस जितना भी कंप्यूटेशन टाइम लग रहा है ना, इट इज मेनली इट इज कंप्यूटेशन टाइम. सो 1 ms 2 ms मैक्सिमम 3 ms ऐसा आ रहा होगा. 3 ms की लेवल पे आ रहा होगा. ठीक है, cool है. I guess if there are no other questions, thanks guys, thanks for tuning in. This is a new season. Next episode is also lined up. Saurabh and me will take it. We'll announce it when it is ready. Cool guys, thanks for joining. See you next weekend.